Welcome to Swift Math Blog. This video shows an extremely simple and fast technique for finding square roots of perfect squares without a calculator. This method works especially well for numbers in the range of 3 to 6 digits, and with a few modifications can be applied to even larger numbers. We will look at finding the square roots of 3 and 4 digit numbers in this video, and in the next video I'll show you how to find the square roots of 5 and 6 digit numbers. Before I delve into explaining this technique, I'd like to explain a couple of simple rules regarding perfect squares and square roots. Given a perfect square with odd number of digits, its square root will contain n plus 1 divided by 2 digits, where n is the number of digits in the perfect square. For example, the square root of the number 400 will contain 2 digits, or the square root of 10201 will contain 3 digits. Given a perfect square with even number of digits, its square root will contain n divided by 2 digits, where n is the number of digits in the perfect square. For example, square root of 9801 will contain 2 digits. Now let's try to find out the square root of 7396. The first step is determining the number of digits in the square root of 7396. Since 7396 has 4 digits, according to our formula, the number of digits in the square root is 2. We observe the leftmost 2 digits of 7396, which is the number 73. We then find the largest single digit number whose square is less than 73. This number is 8, whose square is 64, which is less than 73. This tells us two very important things. One, that the leftmost digit of the square root is 8, and second, the square root is between the numbers 80 and 90. We now look at the rightmost digit of 7396, which is 6. There are two single digit numbers whose square ends in 6. They are 4 and 6. The square of 4 is 16 and the square of 6 is 36. Our desired square root therefore could be either 84 or 86. We now square the numbers 80 and 90. The square of 80 can be obtained very simply by squaring 8 and adding 2 zeros, so we get 6400. And similarly, the square of 90 is 8100. To determine whether 7396 is closer to 6400 or 8100, subtract the two leftmost digits of 7396 from the two leftmost digits of 6400 and 8100. 73 minus 64 gives us 9, and 81 minus 73 gives us 8. This shows us that the square root of 7396 is closer to 90 than 80, and hence the square root is 86. We'll try another example. Let's find out the square root of 529. 529 has 3 digits. According to our formula, the number of digits in the square root is 2. Since the number of digits in 529 is 3, and 3 is an odd number, in the next step we will add 0 before 529. This gives us 0529. We then look at the leftmost 2 digits of 0529 and determine the largest single digit number whose square is less than this number. In this case, the leftmost 2 digits are 05, and the number 2 is the largest single digit whose square 4 is less than 5. This tells us that the leftmost digit of the square root is 2, and the square root is between the numbers 20 and 30. In order to determine the rightmost digit of the square root, we look at the rightmost digit of 529. This digit is 9. Now the squares of 3 and 7 end in 9. So our result could be either 23 or 27. In order to determine which of them is the right answer, we just square 20 and 30. The square of 20 can be obtained by just squaring 2 and adding 2 zeros. The square of 2 is 4 and adding 2 zeros gives us 400. Similarly, the square of 30 is 900. By just observing the numbers, we can determine that 529 is closer to 400 than 900. Therefore, the square root of 529 should be closer to 20 than 30. So we conclude that the square root of 529 is 23, which is the right answer. This brings us to the end of the first part of our video on finding square roots of perfect squares. In the next video, we will modify the method you have just learned a little bit to evaluate square roots of 5 and 6 digit numbers.